Welcome back to my series on being an applied statistician. Today we're going to talk about the Pearson correlation test, which is a test of relationship or association. So let's go, as we always do, to the statistical test decision tree and let's see where this is situated. So up until this point, we have spoken about description, research questions which deal with description, and research questions which deal with difference. Today, we're going to move on to association or relationship. As we always do, we take into account the type of data that we're dealing with. Today, we're going to deal with interval data, which is normally distributed. So if you have a research question, which is an association question or a relationship question, you have interval data, you've tested that it's normally distributed, the test that you're going to use is the Pearson correlation. So when do we use a Pearson R correlation? So please consider the following question. Is there a relationship between the degree of anxiety a student has and the degree of satisfaction that they have from completing a writing task? So we have a question here which has two measurement variables, degree of anxiety and satisfaction. This is in relation to writing a particular type of writing task. And the question we have is there a relationship? Does the degree of anxiety have anything to do with the degree of satisfaction when completing a writing task? Let's enter into a question analysis as we always do. Do I have a grouping variable? No, I don't have a grouping variable because basically I only have one group, right? I have one group of people a group of students in this case, who completed both of these measures. Do I have outcome variables? Yes, I do. I have two, anxiety and satisfaction. One is low anxiety, 5 high anxiety. One is low satisfaction, the other is 5 is high satisfaction. What type of data are these variables? Well, they're interval. Both of these variables are interval data. So what do I need? I need a test that tests the relationship between two interval variables. Okay, here we have a schematic drawing of how the Pearson R correlation test works. And let's take a look at it together. So I have one measure and I have another measure, if you like, anxiety level and satisfaction. And what the test does is it looks at the relationship between these two and it checks whether this is systematic or not. So the question here is there a relationship? And secondly, is this relationship systematic? So let's explore just a little bit what systematic and what a systematic relationship means. So the first thing one can say is a basic understanding of correlation is that two measures have a relationship. In other words, the two scores change, or if you like, co-vary in ways which are systematically related. The best way to understand this is to look at a scatter plot and understand what a scatter plot does. So let's do this together. So here I have a scatter plot. On one side, the horizontal side, I have one variable, and on the vertical, I have the other variable. This point represents the meeting point between variable 1 and variable 2. So if we map out all the scores from all the students by making points like this, so let's say this student got 5 on one variable and 40 on the other, so the point would be over here, or 50 on one and 7 on the other, the point would be on here. Remember, what I'm interested in is there a relationship which is systematic between the two variables? Basically, there are three types of relationship. If you get a blob like this on a scatter plot, there doesn't seem to be a correlation. There's no systematic connection between this variable and this variable. If, on the other hand, you get a pretty straight line like you've got here going up, what this means is if you think about this point here, it's low on one variable and it's low on the other variable. This point over here is high on one variable and high on the other variable. So what we can say about this is that this is a positive relationship in which when one measure is high, the other measure is high. For example, high anxiety is always related or systematically related to high satisfaction. Is that logical? I don't know, but that would be a positive relationship. A negative relationship, and you can see that here the line goes down. What this means is when one variable is low, the other variable is high. And this is systematic across the line. So this variable, this student here, for example, has a high on the vertical, but a low on the horizontal. What do we define this as? We define this as a negative relationship where one measure is high, the second measure is low in a systematic manner. Now, there are ways of interpreting a correlation. First of all, Pearson R, and then we can also see a non-parametric Spearman, is between -1 and +1. The closer to minus or +1 the Pearson R correlation is, the stronger the relationship. The closer to 0, the weaker the relationship. So if you get a Pearson R which is between 0 and 0.2, it's a very weak relationship. If it's between 0.81 and 1, it's a very, very strong relationship. And you can see along this scale all the options that exist. So when can you use a Pearson R correlation? First of all, when you want to test if there is a systematic relationship between two variables. The two variables are both interval data if we're using a Pearson R, and the two variables are normally distributed. Do we have hypotheses? Well, yes, we do. So first, our null hypothesis is that there is no systematic relationship between the two measurement variables. What is my claim? Well, there's three types of claim which are parallel to the types of relationship. First of all, we could say there is just a relationship between the variables without specifying what that relationship is. We could also claim that there is a positive relationship between variables. In other words, that both variables will be high, and that will be a systematic relationship. When one is high, the other is high. And the third claim is that there is a negative relationship between the variables, meaning when one variable is high, the other is low. And with that, we're going to move into JAMOVI and look at the Pearson R correlation in JAMOVI. Now, as you can see here, I've opened up JAMOVI, and this is the front screen. And let's first look at what data we have actually here. So we have two variables. We have anxiety and satisfaction. Both variables go from 1 to 5. If we open up anxiety, actually this is continuous data. If we look at anxiety, it's the degree to which a student has anxiety, low anxiety, or high anxiety. Let's close that. Let's open up satisfaction. This is also continuous data, and this is the degree to which a student has satisfaction after completing a writing task. And once again, we have low satisfaction and high satisfaction, and everything in between. So the first thing we're going to do is we do need these variables not only to be interval, but to be normally distributed. So the first thing we're going to do is we're just going to check that these are normally distributed. So I'm going to open up exploration descriptives. The thing that interests me here is the Shapiro-Wilk. I don't need a mean or a median. I don't need a standard deviation. It is worthwhile looking at the n and missing the number of people who did this. We're looking at the minimum and maximum just to make sure that the scale is actually correct. So let me move anxiety into the variables and satisfaction into the variables. And as we can see, the Shapiro-Wilk comes up here. We have 20 participants in each. That's good. We have no missing data. The scale goes from 1 to 5 as it really does, so we don't have any problems there. If we look at the significance level of Shapiro-Wilk, it's above 0.001, and here as well, it's above 0.001. We're going to consider both these variables to be normally distributed in this case, and we feel comfortable in moving into a Pearson. However, before we do that, we do want to look at the scatter plot. So let's bring up a scatter point. Let's put anxiety in the x-axis and satisfaction in the y-axis. And let's ask for a linear line. So when we look at this, what we can see is that this is a line that is going down. So this suggests, as you already know, a negative correlation. In other words, if they have a low anxiety score, they're going to have a high satisfaction score. If they have a high anxiety score, they have a relatively low satisfaction score. Okay, now let's go into analyses and let's actually do the correlation. Now the correlation is found under regression, and we're going to go to correlation matrix. Before we move over the variables, let's see what we want. So we want a Pearson. We want to report significance. We want to flag, which means to show with star asterisks. We want the N because that's actually what we want. Now, we also want to consider what is our hypothesis here. What do we actually think? Do we think that high anxiety would cause low satisfaction? Do we think that high anxiety will cause high satisfaction when you complete a task? In this particular case, I'm not really sure what the relationship between anxiety and satisfaction is, so I'm going to leave it just as correlated. If I did have a direction, if I did think it was positive or negative, I can see in the scatter plot that it is negative already. But I think my hypothesis in this case, I don't really know what anxiety is doing to satisfaction. Okay, let's move anxiety into my variables box and satisfaction into my variables box. And what you can see comes up here is a correlation matrix. This is anxiety, this is satisfaction. And what I'm interested in is these two scores. This is a negative 0.04 455 correlation, and it is significant at the 0.05 level. What does this mean? It means that I have a significant relationship. This is a real systematic relationship, and it's negative. Let's explain it for a second. Basically, when satisfaction is high, anxiety is low, and when anxiety is high, satisfaction is low. Okay, now all that's left to do is to report this particular finding. The final thing to do here is to report the Pearson correlation. Let me read through the language, and you can already see the arrows where the information actually exists. This is a relatively simple test to report. There was the significant negative correlation between the degree of anxiety a student feels and the degree of satisfaction they feel when they complete a writing task. What this suggests is that increased anxiety will lead to decreased satisfaction. That's what a negative correlation actually means in this particular case. What do you report? You report the Pearson R statistic, in this case 0.45. You report the number of participants, in this case 20, and you report the significance level. As I said, a very simple test to report. I hope this video has been helpful to you. I hope this helps you in your research, and I will see you all in our next video.